part 1, I've got to sketch this curve, giving the coordinates of all points of intersections with the axes. So I've got y equals 2x squared minus x minus 3. I'm going to try and factorise this because that's often a really nice way of seeing what's going on. So I have to be 2x in the first one and x in the second one. To get 3, it's got to be 1 and 3. And that'll be the numbers coming in here. One's positive and one's negative. Don't forget, one's going to be hit by the 2, and I need to get minus 1 altogether. So if this one is 1, that'll give me 2 x's, and if that's 3, that'll give me 3 x's here. That's looking quite good. And so I want the 3 x's to be negative, so it'll be negative like that and positive like that. So the roots, so when y equals 0, we get 2x minus 3 times by x plus 1 equals 0. So either 2x minus 3 equals 0 or x plus 1 equals 0, and that'll give me 2x equals 3 or x equals 1 and a half or x equals minus 1. So that gives me my points to start off with. So I've got minus 1, and I'm going to do it to scale. If I do it to a scale, that's minus 1 to there, so it's going to be, that'll be 1, 1.5 would be here. And that's important because it's symmetrical. The x squared graph or quadratic graph is symmetrical. So that's negative 1. You need to label these, and that's 1.5. I need to know where it goes through both axes, so I need to know when x is 0. When x equals 0, that will give me 2 nothings. Take away nothing will be minus 3. Y will equal minus 3, so I can put in minus 3 anywhere by there. But now I know that the minimum point is going to have to be there because it's going to be symmetrical about that. So it's going to have to come down like so. It's not too bad. It's meant to be quite symmetrical. Might want to taper up a bit more there. But notice the minimum point is not at minus 3, it's somewhere over here. So that's the first part. I stated the 3 points it hits here. Part 2, I'll do it in red up here somewhere. Hence or otherwise, solve the inequality. When is this greater than 0? Just check it is the same. So when is it greater than 0? It's greater than 0 for all the x values across here and all the x values here. So that'll be x is less than minus 1 or x is greater than 1.5. And I can't put it in one go because they're two separate regions. If I had to solve an inequality, I'd always do the sketch first anyhow. And finally, part 3, I'm going to go back to blue. Part 3, given this has got no real roots, find the set of possible values of the constant k. So that's just check it is my same curve. When's it equal k? Well, k has got to be anywhere. I'm not sure I'll do it in green. Has got to be anywhere down here. So x, that could be, or what that is, but any of these values, there'll be no real roots because it doesn't hit. Get really close, but so I need to find out the minimum point there. So personally, what I would do is I'm going to find the stationary value. So I'm going to differentiate it. dy by dx equals 4x minus 1, and so that equals 0. So 4x minus 1 equals 0. 4x, oh, that's for the stationary point. For stationary point. So 4x equals 1. So x equals a quarter. And then I want to find out what the y value is. When x equals a quarter, y equals 2 times a quarter squared, so that's 1 over 16, minus a quarter minus 3. I want to make sure I get this right. 2/16, that's 1/8. Take away a quarter, that's 2/8. Take away 3, and so that will equal minus 1/8 minus 3 will be minus 3/8. 3, not 3/8, minus 3 and 1/8. And so that will be the coordinates of that point, which is a quarter and minus 3 and 1/8. And so therefore k has got to be less than minus 3 and 1/8, and it can't be equal. And that's question 8 done.